Who is Dr. Rodney Kawecki? He's a physicist and author of several books on physics, including one on general relativity. But his most famous work is his redesign of Einstein's theory of relativity. Okay, here's what he did. He took Einstein's idea of a Higgs field that permeates all of space-time and interacts with particles, giving them mass, and he expanded on it. He proposed that there are multiple layers of these fields, each interacting with different particles, and these interactions create what he calls a deep space effect. This effect allows for superluminal travel, meaning faster than light travel. And it also gets rid of Einstein's speed limit, his inertia, and his time clock. In other words, it completely rewrites the rules of physics as we know them. His most recent book, The Absolute Theory of Everything, lays out his case for this new physics, and it's a fascinating read. So what do you think? Is this the end of Einstein's reign at the top of the physics world? Or is it just another crackpot theory? You decide.
Today, 100 years later, a new scientist is on the block. He has redesigned Einstein's time travel, speed of light watch, stopping time altogether in relativity theory and recover it. You see, time is not a real thing. As such, nothing can happen to it. It cannot contract, as Rilla asserts. But in this new physicist's mind, space field mass interpretation can. You see, when looking up, you're viewing backwards in time due to the vast distances involved. A local ship traveling forwards by acceleration, but its journey backwards through space, through the looking glass, if you will, is governed by the same rules as the time traveler who ventured into the unknown 100 years ago. The only difference being that this new scientist has incorporated Einstein's theories on mass and energy equivalence into his model. So now, not only does time stop for the traveler, but also for all observers. In quantum physics, space-time never stops. Why? Because it's not a physical thing. It's a tick-tock illusionary machine. It actually doesn't even exist. In Rodney Kawecki's eyes, the definition of time is space that contracts as acceleration renders on. By doing this, time is mobilized. You can journey forwards in time to your destination, and travel backwards in time in your ship, and journey a very short cut in time to reach your destination. Infinite mass does not exert any gravitational pull. If we were to imagine a scenario where an object with infinite mass were to collapse in on itself, it would create a black hole. And if we were to continue to accelerate that object, we would eventually reach a point where time itself would cease to exist. This is because as the object accelerates, its gravity becomes so strong that not even light can escape, collapsing the object further and further until it reaches a singularity, where space and time are no longer separate. They become one. This is the point of infinite density, where all of the mass is concentrated. Why does an infinite mass show itself? Because the density field of space is almost zero. And deeper, even yet at the pure vacuum corridor, it is exactly zero. At space's low-density realm, there exists no gravitoric interference or interactions. Unlike Earth's 1-gram gravity field, the space field density gravitation reads zero. In finite mass, it cannot be more. This is the proposal of the quantum physics framework. It's true, but little is published about the zero vacuum field. But now, it is. There are two reasons why the vacuum field has not been observed yet. The first one is that the human body is not adapted to such a low-gravity environment. Our bodies would start to fall apart. The second reason is that we cannot shield ourselves from the Earth's gravitational pull, and so we have never been able to create a true vacuum bubble around us. However, with the help of quantum physics, this can be done. We can create a wormhole-like structure that will allow us to escape the Earth's gravity and go into the vacuum of space. And then we will finally be able to see what is beyond our world.
But let's get real. Relativity asserts that if his special relativity spaceship were made of tachyons, his ship could travel straight through solid planets and stars. Kawecki corridors are real.